Look at these matrices. Can you figure out the type of solutions? What happens if k plus 2 is 0? So if k is minus 2, row 2 becomes 0, 0, 0, 0. Can you figure out, is the solution a line, a plane, or no solution? The solution is a plane because the planes are coincident. Also, we often call this case infinitely many solutions. So, this is one type of solution. Are there any other possibilities, students? Second case, if k plus 2 is not 0. If k plus 2 is not 0, that means when k is not negative 2, this means k can take any value except minus 2. The second row of the matrix is 0, 0, k plus 2, and 0. Please take note, k plus 2 cannot be given a specific value. IB student, can you recognize which case this is? It is 0, 0, m, n case. In this case, the two planes intersect at a line. So let's go back to our matrix 1, 2, negative 1, 6, 0, 0, k plus 2, 0. Can you find the equation of the line? Look at the second row. The equation is 0x plus 0y plus k plus 2z equal 0. No matter what value k takes except minus 2, the z coordinate is always 0. I repeat, knowing that k plus 2 is not 0, z is always 0. Back to first row of the matrix. Can you write the equation that connects x and y? The equation is x plus 2y plus negative 1 times 0 is 6. X plus 2y is 6. Student, do you know what am I doing now? I am trying to find the equation of a line when k plus 2 is not 0. Come back, please. I know some of you might be feeling lost. Let us continue. Now, I let y equal t. Then x equal 6 minus 2t. And z equal 0. Can you see? This is the parametric form of the equation of a line. I can rewrite the parametric form as the vector equation of a line. It becomes xyz equal t. So z is always 0, y is t, and x is 6 minus 2. You can use lambda here instead of t if you prefer. So when k plus 2 is not 0, the two planes intersect along a line, and this is the equation of their line of intersection. Intersection along a line has infinitely many solutions as well. So now we have seen that the value of k completely changes the relationship between the two planes. In the first case, the planes are coincident. In another case, they intersect along a line. And we even found the parametric and vector equation of that line of intersection. And before we move on to part 3, here's the important thing. IB exam questions love to test these cases, and students often lose marks by mixing them up. So in part 3, I will give you a clean summary table and a final checklist so you can recognize these situations instantly in an exam.